What's up, .NET developers? Are you just getting started with AWS? Are you curious about it in general, but you're having a hard time navigating all the different terms and topics that exist? Well, in this video, we're going to go through some of the high-level concepts of AWS and look at some of the ways that we can programmatically call AWS services from our .NET applications right here on AWS for the .NET developer. How's it going, everybody? Another edition of AWS for the .NET developer. I'm Isaac Levin. If you're liking some of the content here, be sure to like and subscribe at the bottom and tell me all sorts of great things that you're building with .NET on AWS. So if you've been following along, we've already talked about cloud computing at a high level and what it is and how AWS comes into play there. We've also taken a look at some of the tools that .NET developers can use to build really rich experiences on AWS. And now I think it's a good time for us to start thinking about some of the core principles specific to AWS and how we can actually build solutions that leverage great AWS resources. So here's some of the topics that we're going to be talking about today. So first and foremost, we're going to be going over what accounts are and what they're not. So in the AWS world, there's a lot of things that are tied directly to accounts, and it's important to have an idea of what accounts are. We'll also go over organizations and how they come into play when we want to govern or have some sort of centralized management across all sorts of accounts you might be having at our organizations. We're also going to talk about resources and how resources come into play as we're pertaining to building out AWS services specific for our applications. We're going to talk about identity access management, or IAM for short, which is the overarching security mechanism that exists inside of AWS to provide really rich experiences for building applications. And finally, we're going to take a look at some code. We're going to be using AWS resources with all the different credentials options available to us as .NET developers. So first and foremost, let's talk about some accounts and organizations. So in AWS, accounts are the canonical way to provide authentication and authorization to AWS functions and resources. So when you first sign up in the AWS console, you use an email address. The user tied to that email address is known as the root user or the admin of the account. Once your account is created, you'll have an AWS account ID, which is the unique identifier for the account you have just created. You'll see this ID often, as many AWS resource names, or ARNs, contain the account ID in them. If you're a part of a large organization with many applications and services, all with different cost centers or business units, it probably doesn't make sense to put them all in one AWS account. AWS Organizations can act as a centralized account management mechanism to provide some ease of use experience like consolidated billing, hierarchical grouping of accounts, control access, and standardized resource tagging throughout our account. There are many benefits to organizations, and I'll put a link in the notes to learn more about them. So let's talk a little bit about resources. To connect programmatically to a resource, you have to have a URL. And the endpoint is the entry point for any AWS service you want to hit, whether it be from the SDK, CLI, or just the APIs. If the service supports regions, then those resources in each region are independent of similar resources. Regions are collections of AWS resources in specific geographic areas. Each region is isolated and independent of other regions and provide fault tolerance, stability, resilience, and also can reduce latency. Resources you create in a region do not exist in another region unless you use the replication feature provided by that service. You have the ability to enable and disable regions based on the needs of your organization from the AWS console. Service quotas are configured limits to how many of a specific resource you can create in a specific region. You can request increases for some quotas, but some cannot be increased. You can view and request quota increases using the AWS console or the CLI. As we build more and more resources to create our applications, it might be beneficial to organize them in a particular way. Using tags allows you to assign metadata for your resources using key value pairs. And finally, Amazon resource names, or ARNs for short, are the unique identifiers for our resources. So they all follow a particular format depending on the type of resource they are. For instance, if I have an S3 bucket in West US 2, that'll all be a part of the ARN. When we talk about security or building applications that consume resources, we need to take into account identity access management, or IAM for short. So as I mentioned a bit earlier, IAM is the overarching principle of how we build applications that consume AWS services. And there are 4 specific areas of focus that we have as it pertains to IAM. The first one being users, which are specific individuals. They can have logins or programmatic access. So think like keys or secrets. You then also have groups, which can be a collection of users. For instance, senior developers. You also have this idea of roles, which are a collection of policies. For instance, if you wanted to have read-only access to a database, you can allow non-AWS services to call AWS services as well. And finally, policies, which are low-level permissions to AWS resources. They are simple allow or deny commands. So here's an example of an IAM policy for control of an AWS or Amazon Simple Storage Service or S3 bucket. It has a SID, which is a unique name, the effect I want to take place, the actions, in this case, being able to perform any action that starts with S3 in any resource in my account. I can fine-tune this if I want to be a particular ARN if I want as well. So let's go through a practical example of IAM in practice. So currently, I have 2 users. Those resources are called Andy and Jeff. Andy and Jeff are both senior developers, so I'm going to assign them to a group. And I want to ensure all members of the senior devs group have full access to Amazon S3. So what I can do there is I can specify a policy that provides full access to S3 and grant that role to that, or grant that policy to that role. So that seems pretty clear. However, what happens if Isaac joins the company? Isaac is not a senior developer. Isaac wants to be able to have read access to S3. So how do we do that? Well, we create a role for Isaac specifically, and assign that policy to that role. So Amazon S3 read-only access, for instance. So now Isaac has read-only access to Amazon S3, and Andy and Jeff have full access. So this is a really simple example, but it shows you how you can fine-tune roles and policies for different groups or different users and different groups of users. So what are some do's and don'ts as it pertains to IAM? So the first thing is you want to enable MFA or multi-factor authentication to work on your accounts. So there are tons of options. You can use things like FIDO keys. There's different applications on different mobile devices that support MFA. You also, when you first create an AWS account, you have that root user that I spoke about a little bit earlier. You only should be using that root user account when you're looking to complete tasks only that user can perform. Activities like generating access keys or connecting services should not be done. You should be creating different users and creating access keys for those users, not the root user specifically. Amazon follows a follow least privilege model. So you should only be granting permissions you need to have for a particular task for a particular resource. You may need to start out with broader permissions as you're learning the service or you're trying to fine-tune what you're trying to accomplish. But eventually, as your use case matures, you're going to want to whittle down those permissions to be just the permissions you need for that application to do what it needs to do. You should be taking advantage of AWS managed policies for common use cases as well, like reading a database or uploading to an S3 bucket. These policies already exist, so you should be taking advantage of them. And when you're updating policies, ensure that you're aware of what impact that will be. The worst thing that can happen is adding an unneeded or removing an essential permissions and causing issues with applications your customers may currently be using. All right, so let's talk a little bit about some of the different ways that we can consume AWS resources using credentials. IAM and how we define access to AWS services lets us talk about how we can leverage all these concepts as well, build applications and interact with AWS resources. In our tools video, we walk through setting up AWS shared credentials, which if you remember when I ran the AWS configure command in the CLI, it created a file. And that file was used by all of our favorite tools, the CLI, AWS tools for PowerShell, the popular IDs like Visual Studio, Visual Studio Code, JetBrains, Writer. So this really is valuable as we can focus on building our application without having to manage countless accounts and different configurations. However, in some cases, it makes sense to move away from those shared credentials, especially as we start to look at following the least privileged approach that I mentioned earlier. This is where we can create new users with new roles and policies and use those credentials for building an application. A great example is building an app that just reads from a database. It is against our best interest to give it any access other than read, so we should be using credentials that only have that shared access. We can also do things when you're creating a new user and adding that new access and secret to our application. Initially, it might make sense to add those configurations inline, but since .NET has great configuration management story, it makes even more sense to add them to our settings file and load that using the built-in ConfigurationBuilder constructs. This way, we can seamlessly switch between environments as we develop locally just by updating our build configuration. One downside to the above approach is that the access key and secret are stored in plain text. If you are building apps on Windows, you can also take advantage of the SDK store, which allows you to create a specific profile that leverages it and stores those secrets encrypted, and they are specific to a particular user on a particular host, which adds to another level of security. But once we're at the point to deploy our application in AWS, we have another more secure option to enabling access to particular services. The preferred approach is to configure IAM roles that are deployed, application will run under, and assign the least privileged permissions from there. This ensures that access to your AWS resources are secure, as there are no access keys or secrets being leveraged. And we'll have another video in the future where we talk a bit more about IAM roles and how we can configure them. Now let's actually jump in some code and take a look at some of how we can take some of these examples that we've just had and actually communicate with some AWS services using them. So what you're looking at right now is a .NET 6 Blazor server application. And this application is pretty simple. I want to be able to list the top 10 movies that exist that are represented in a DynamoDB table. So how am I actually doing that? So the first thing that I do is I set a DynamoDB context, and then I look for movies that have a release date that is not null. I get those movies, and then I order by descending the top 10. So the output will be 10 movies ordered by popularity. So how am I actually able to communicate with this DynamoDB table using AWS Credentials? So as we were talking about a bit earlier, or in a previous video, when you use AWS configure inside the AWS CLI to build out a profile, what ends up happening is a file is stored on your machine. And that file is actually used not just by the CLI, but also via all of the IDs that you have configured to actually communicate. So you specify, you remember in that previous video, we created a tools user, and then we configured the AWS CLI using the access key and secret from there. So if I actually start this application, what will happen is that let's actually do a quick watch on client while this application is running. So as you can see here, client is null. Let's just step over that. And now client is populated. So if we scroll into the credentials section and zoom in, you'll see right here that there is a access key and secret for this particular application because it was loaded from that file. We can actually take a look at that file right now. So let's actually stop debugging here. Let me go over and get where that file is. Bear with me for a second. All right, and then let's just go open it and let's just go code. And then let's open up that file. Oops, I don't have code, I have code insiders. Okay, so this will open up Visual Studio Code that has those secrets in there. So you see the access key and secret. So that's really, really valuable when we are just getting started with debugging. But what happens in the situation where I want to configure specific access for a particular task? Like for instance, in this case, all I want is read access on that DynamoDB table. I don't need write. I don't need execution of Lambda. I don't need any of those other things. So let's actually go through the process of creating a new user and then setting it up using that. So I'm going to pop open to my AWS Management Console here. So I'm going to go there and I'm going to go to Security Credentials. Wait for this page to load, and then I'm going to create a new user, and let's just call that user. Wait for the page to load again. Let's create a new user. Go click Add Users here, and then I'm going to specify, let's just call it Popular Movies, right? And then I'm going to specify an access key for programmatic access. So specify the permissions here. I'm going to attach an existing policy like we were talking about earlier. And let's just go DynamoDB and search. So DynamoDB read-only access. That's the policy that I want to attach for this particular user. Skip over because I don't need any tags, review, and create. So now that it's created, I have an access key and an access key ID and an access secret. I can download this file and we'll do that in a second, but I want to be able to actually use these keys in my application. So I'm going to copy this. I'm going to go back into Visual Studio. And what I want to do is I want to specify my Amazon DB client. I want to specify that to use these new secrets. So I can actually do that here. Let's comment this out. Let's just go client equals new Amazon DB client. And inside of here, I can actually specify a new Amazon, AWS Credentials basic AWS credentials. So it's going to specify that in the runtime. So let's just do that. And then you can specify a key and a secret here. So I'm going to specify that key that I shared earlier. And then I'm going to grab this key, go back in here, specify that. Oops. Take out that. And now I have configured a new client that's going to use these new credentials that I created earlier. And we can actually validate that. So if we run this again, we're going to see that the client is populated, and I'll show you the page actually loading in a second. It's going to pop open on a new window. All right. Oops. Let's just F5 out of that. So as you can see, most popular movies, right? So it's still working. So that's really, really great. However, since we're building our application in ASP.NET Core, we really shouldn't be putting our credentials, our key, and our secret inside here. We can actually take advantage of the configuration builder and all the great dependency injection that exists. So what we're going to do is I'm going to get rid of this for right now. And then I'm going to create in my app settings file, I'm going to create two new values. So let's just call this access key. That's a string, and then access secret. And that's also a string. Let's get those values from here. There's the key, or there's a secret, sorry. And then let's copy that. Okay, so basically what I'm doing here is I'm storing this in the app settings. And as we remember, if we're building ASP.NET Core applications, we can actually access this directly. So how do we actually do that? So I'm going to create a new constructor for DynamoDB service, and I'm going to pass in an iConfiguration variable. Let's just call this config, right? And then I can actually specify, everybody who has seen ASP.NET Core is recognizes this. So this is an iConfiguration, and that's going to be configuration. And then inside of here, I'm just going to wire up that. So basically what I've done here is I've referenced an instance of the configuration. So I can then go into my credentials, and I can go configuration, get value, and that value is a string. And then inside of here, access key. And then we'll do the same thing for our secret. All right, so let's run this to make sure it's still working. Let's take this breakpoint out. All right, let's move over here. Up, and there you go. See, most popular movies. So that's actually taking advantage of these the app settings that we have here. So the access key and secret, and that's being loaded in via configuration. There are additional things that you can do here. For instance, if you want to specify the region here, you can do that. If you have specific other criteria like logging that you want specifically for AWS, you can actually load in AWS options as a part of that. And maybe I'll have another video about that in the future. There's one additional thing that I think is pretty cool to showcase as well. So I mentioned earlier that we can actually take this file here. Let's just do that, and let's just download the CSV of it. So I have the CSV here. And so the problem is when we have our code like our settings like this, is that when in the debugger they're actually stored as plain text here. So we have the ability to use the Windows SDK store to be able to encrypt those particular secrets. And I can do that inside the AWS Explorer here. So I can actually create a new profile, and I can change it. Let's just call this new profile, let's just call it popular movies. Popular movies, and I'm going to change the storage location to the .NET encrypted store, so AWS .NET SDK store, and I can actually import this to a CSV. Let's just go to my downloads folder, there, and it's going to specify then. And then I specify my region here and hit OK. And then I can actually take this code out, those secrets that I had earlier, so comment that out, and then we can go back to our other DB client, right there. And then if we run this and we open up that client, we'll see that those new keys are actually encrypted. Let's put that, oops, forgot to say a breakpoint. So, all right, so we have the client here. Let's open this up, client config credentials. And as you can see here, it's a different secret key as it was earlier, but now it's encrypted. So let's actually do something else just for grins. Let's actually open up VS Code. And so as you can see here, there's that default credentials that we had here. Let's actually open up the SDK version of those credentials. And that is, just pulling that up on a different screen here, so I apologize. So let's open this up. Code insiders, and then let's specify this, JSON. So as you can see here, it's stored on my machine encrypted. So it's tied to my particular computer. So the only app identity that has access to the decrypted version of these secrets is my code. So that's pretty cool. So I think one of the things that is really important to call out here is there's a ton of configuration options you can do here. And how is this actually done? So if I go over to my program.cs and I take a look at my builder that I've created, I have a little region that I've set up here for SDK setup. So getting the AWS options. So that's in the situation that if you have a large section of AWS specific configuration inside of your app settings.json, that's how you load that into there. I add the default options that basically gets us access to those credentials that we mentioned earlier. And then this actually wires up all the service clients, in this particular instance, our DynamoDB table, with that client. And then I just add a singleton for that DB service that I've created. So at the end of the day, there are a ton of really interesting things that you can do inside of AWS. So blurry now. There's a ton of interesting things that you can do inside of AWS, and hopefully they showcased the high level concepts that we have going on here. And we talked about accounts and organizations and IAM and the different credential options that we have to actually be able to build .NET applications that interface directly with AWS. So that's the video for this time. Stay tuned for next time, and I hope you have a great day. And I really want to see some of the stuff that you're building with .NET on AWS. Take care.